we've got a quadratic equation here. At this point, how would we solve that? First of all, just type your answer in chat. What method would we use to solve that at this point, given what we've already learned? Type your answer in chat. Okay, Carrie, you're correct. How come completing the square?
There's nothing to like factor out.
Okay, so yeah,
It's set to zero.
Okay, it's set to 0. Good. There are no magic numbers that multiply to AC, which is 14, right? And add to -3. So magic numbers don't exist, right? So we're not able to find magic numbers and then factor by grouping or use slip and slide, right? If we want to use slip and slide. So that's just not really an option for us. Factoring is not an option. How come we can't just isolate X right away?
Because there's always going to be like two possibilities because of the square. So you're either going to have like a positive or a negative, and you only get like one answer.
Well, okay, no, that part, we're always going to get two answers, right? If it's quadratic, we're always going to get two solutions. But I was looking for something a little simpler, and you guys are complex thinkers. You probably just looked right over the top of my dumb question. We can't isolate X because there's an X squared and an X term, right? So we can't just use the really simple method of just reversing order of operations and isolating X. So the only avenue left for us is completing the square, right? Everybody agree? Okay. Completing the square is, sometimes it's easy and convenient to do. Why in this case might it not be so convenient for us to complete the square? It's going to work. It always works. If I start with the quadratic equation in standard form. Yeah, I'm going to get fractions, aren't I? Yeah. Because when I've got to get that, I've got to isolate the X squared, not isolate it, but I've got to get a coefficient of 1, and then I need to get the constant on the other side. So look what's going to happen. I'm going to end up with, if I want to complete the square on this thing, we can already see that it's going to be a little bit messy, isn't it? Right, I'm going to end up getting 2x squared minus 3x equals -7. I've got to divide both sides by 2, and I get x squared minus 3/2 x equals -7/2. That's going to be a little bit of it's not impossible. We can do it. It's not even that horribly difficult, but it's just almost a little bit annoying, isn't it? That we've got b in this case is equal to -3/2. And so when we get our half of b and we square it, we're getting lots of fractions involved, aren't we? Right? It works, but maybe there's a better way here. Rather than having to complete the square every single time, does anybody have a suggestion how we could maybe just complete the square one time and then get an answer that we could always generally use? You see what I'm proposing there? This is a really powerful concept in math. Is there a way that we could just do the job of completing the square one last time and then never really have to use it? We always have the option, but is there a way we could do it just one time and be done with it if we choose to? Anybody have an idea? Well, what quadratic equation would I use? I can't use, like, I could solve for this one, but the next one I give you is going to be different, right? Okay, so Rebecca's got a good question here. Are we going to use the quadratic formula? Yeah, you guys remember there's one more really good method for solving these quadratic equations, right? And that's the quadratic formula. And that's the only one we haven't talked about. So you're correct. That's where we're going with this, right? But how do we get to the quadratic formula is really what I'm after right now. How do we get to that place? How do we get there? How could I solve a single quadratic equation by completing the square and get a result that's going to work all the time? There's a problem, isn't there? Because any problem that I pick is going to have its two specific solutions, and that's it. It's going to be different from the next problem I give you. Or is there a way we could do just solve a single problem? Any ideas? So here's one example. What if I gave you this one here? Let's say I want to solve, okay, that was, now next problem I want you to solve this one. 7, right? Okay, over equals negative 11. Well, if the values of A, B, and C are always different, how can I ever get a single solution that's going to work in all cases? What should I probably do instead? Any suggestions? Okay, well, I'm going to give you a hint here. So this is something really powerful in math. Anytime we solve a specific problem, we get specific solutions that are only useful in the context of that specific problem, right? But in math, if we're able to do the algebra to solve a general equation, then the answers are also general. So Andrew's got an idea. Substitute numbers. Okay, substitute numbers for A, B, and C, and then create a formula we can plug into. Okay, so yeah, something along those lines. Like, right, what if we started with, if we want to prove a relationship or a formula, we can start with a general equation where nothing is specific, right? So what if we take a general quadratic equation in standard form? Ax squared plus bx plus c equals 0. Give me a thumbs up or thumbs down here, everybody. Click your cameras on for a second. Does everybody, or just type it in chat, does everybody agree that that represents every possible quadratic equation in standard form, right? We could plug in any numbers we want for A, B, and C to create any conceivable quadratic equation in standard form, right? We've got all avenues covered here. Okay, so then if we were to start with that quadratic equation in standard form, right? The most basic form, nothing specific. And if we solve that for x, we're going to get x equals some solutions. What do you think we're going to end up with in our solutions? Let's not be specific, but I just want to know, I'm going to get x equals, and what kinds of things should end up in our solution if I start from this point and I solve for x? Am I going to get specific answers like x equals 9 or 11? No. What am I going to get instead? Okay, I'm going to get by variables, I'm going to change that word to parameters, right? I'm going to get the values of A, B, and C, which really aren't variables. X is the variable. A, B, and C are what we call parameters. because those are the specific values that we can select to create any function, quadratic function that we want, right? Did everybody agree with that? If we were to execute all the proper algebra steps, we should be able to get x in terms of a, b, and c. Okay, let's do that. Let's just go through the process. What do we have to do? Remember, we had to get the x squared. We had to get the coefficient of x squared to be 1. We need the x squared term and the x term by themselves on one side, right? So first I would subtract c. Good. Ax squared plus bx equals negative c. Now what? Okay, we got to divide both sides by a because we need the coefficient 1, right? So we divide each side by a. And that, if I split these up, that's going to give us x squared plus b over a times x equals negative c over a, right? Okay, so now what? Now what? Look what we've got here. Coefficient of x that we used to call b. That's kind of inconvenient now, though, isn't it? Right? Remember, we used to say what's b and what's half of b? Right? I mean, that's not very convenient because we've got b's in the expression, right? So what if we call that like a capital B instead? We used to call a b, we're calling a capital B. Well, dividing by 2 is the same as multiplying by 1/2. So a couple days ago, what we would have called half of b, or b over 2, is going to be b over 2a. Sure, right? I'm multiplying by 1/2, aren't I? That's all I'm really doing. Cross 2a, right? And then, but what I want to do is I want to add that squared to both. So if I square both parts of these, on the top I'm going to get b squared. What do I get on the bottom when I square the bottom? What's 2 times a quantity squared? Let me write this in 2 steps. How about? Well, I got to square 2. The bottom is 2a times itself, so I get 4a squared, right? Okay, so that's what I've got to add to both sides, isn't it? Everybody agree? I'm adding half of the linear coefficient, half of the coefficient of x squared to both sides to complete the square, correct? Okay, so I'm going to write that on the left side. I'm just going to form b over 2a squared. On the right side, I'm going to go ahead and square it out. So I get b squared over 4a, just like we always do. Oh, 4a squared, sorry, right? But I've added the same thing to both sides, okay? On the left side, what does this factor into, right? We always know we get a pattern here, right? I get x plus half of the coefficient of x, quantity squared, don't I? Everybody good with that? Remember our pattern? So whatever we were squaring here is what's getting added to x to create our, that's our magic number, right? Our single magic number that shows up twice is half of the coefficient of x, okay, when we factor it. What about on the other side? Well, I've got to add these fractions up. How do I add those fractions up? You know, I've got to subtract c over a from b squared over 4a squared, right? What do I have to do always to add or subtract fractions? Okay, common denominator. All right, so to get a common denominator here, what am I going to have to, Chloe, what do I have to multiply the blue fraction by here on the top and the bottom to get a common denominator?
Um, wait,
I need to get a 4a squared on the bottom, right?
yeah,
So what would I have to multiply the bottom by here to get 4a squared?
4A.
There you go. And I have to multiply the top and the bottom by the same thing, right? So I'm multiplying by 1. Everybody agree? Okay, so what's that going to give me then? On the top, I've got a common denominator now of 4a squared. On the top, I'm going to get my b squared. Let's do this so we can track that minus sign. Minus 4 times a times c, right? If I put those in the proper order. Everybody agree? Okay, give me either a thumbs up or in chat, give me a yes or a no. Are we okay on steps we've taken so far? Okay, let me hear from everybody. Either let me know in chat or with your thumb. I've only heard from one person on chat.
So the A has a B squared in front of negative 0A. Is that just for convenience?
Say it again.
So the magic number is what we add to both sides.
Well, we add the magic number squared to both sides.
Yeah.
Right?
And you put it in negative 0A.
I put it. Oh yeah, I put it. Yeah, exactly. I put it in front just because it's convenient. I added it to both sides. You're saying, right? But it's because this is positive. I just put the positive number in front of the right in front of the negative. Didn't have to.
Yeah.
Okay. Now that.
Wasn't a question.
Yep. That's it.
For convenience.
Just for convenience. Yep. Exactly. Yep. Okay. So now what? Okay, well, now to solve for x, now we can point to a single x. So all we have to do is isolate it by square rooting both sides, right? Everybody agree? Okay. So if I'm just going to do this so I make sure I include all the steps here. Right, so what do we do? Well, we're just going to square root both sides. Right, and the square root undoes the squared. So we end up with x plus b over 2a equals, got to add my plus or minus, don't I? And then what about here on top? Well, I can split this into two separate parts, right? I can take the square root of the top and the square root of the bottom separately. So I get the square root of b squared minus 4ac divided by the square root of 4a squared. But what's the square root of 4a squared? Right? I can use my properties of exponents here. I know that the square root of m times n equals the square root of m times the square root of n, right? So the square root of 4a squared equals the square root of 4 times the square root of a squared. Well, isn't that just 2a? Everybody agree? Okay, so then we end up with x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 2a. And my last step would just be to subtract b over 2a, which I'll put in front of the plus or minus, right, from both sides. Well, look at that. That should start to look a little bit familiar, huh? X equals, I've got a common denominator here, right? So I could just write that as one fraction with a common denominator. I could just write that as negative b plus or minus the square root of b squared minus 4ac all over my common denominator 2a. Have you seen that before? What's that? So you guys, you've heard my song, right? My quadratic formula song. I think, wasn't Mrs. Robinson, didn't she start to use that one? Yeah, I've got some bad news. I looked for it online and I can't find it anymore. After all these years, I think it finally went away. So you might be the last group that got to hear the quadratic formula song. You should feel pretty special about that one. So there it is, right? There's our quadratic formula. Okay, how about that? Now, that ought to give you some mathematical goosebumps. That's pretty cool that we're able to do that, right? We're able to start with a completely general equation, and by solving for x, look what we did. We came up with a formula. That is how formulas are born. You start with a general equation and you solve it, okay? There's real power to that in math. If you can solve something very, very generally, your result is also general. And that's a powerful thing, right? Okay, so now the advantage of this is we really never have to complete the square ever again if we don't want to. You still might choose to if it's easy to do, but now we've already solved the most basic general quadratic equation by completing the square, and so our results will always work. Okay, and this is, as you know, what we call the quadratic formula, right? So how does that work? Well, quadratic formula, then, it's really simple. If we want to apply the quadratic formula, we can always solve any quadratic equation by using it. If we put the first step would be put the quadratic equation in standard form, so it's set equal to 0. Now, here's one that sometimes gets skipped. We want to make sure that a is positive. When we use the quadratic formula, because we've got a in the denominator, we do not want a to be negative. That's okay, right? Once I put my quadratic equation in standard form, I can multiply both sides by -1 to change all the signs if I want to, right? And so if a starts off negative, well, I'll just make it positive by distributing a negative through both sides. And then I just evaluate the quadratic formula. No big deal. Okay, so let's just try a little bit of practice on this. And you guys all know how to use this. The only thing remaining for us to talk about is I just want to go through a little bit of practice using it, try to pick some harder problems. And there's one other part of this that's really useful that I don't think we're going to get to today, but we'll get to on Friday. Okay. Well, you know what? We're about out of time, actually. We've only got 2 minutes, so maybe we can do one thing to prepare for next time. What's wrong with this equation here? What do we have to do? Okay, we got to subtract 2x. Just in general, what do we have to do here?
Get them all on the same side of the equal sign.
Okay, yeah, we want to put this into standard form, don't we? Right? Now, technically, this quadratic formula works for any values of a, b, and c, right? Any real values of a, b, and c. They don't have to be integers. They don't have, but it's convenient for us to apply the formula if we're able to make the values of a, b, and c convenient, right? So the first thing we might do here is push everything to one side, for example. So we end up with, would everybody agree? I want a to be positive, so I'll move everything to the left, right? So I get 1/4 x squared minus 2x plus 11 halves equals 0. What's the very last thing I could do here to make the values of a, b, and c much more convenient? Okay, I could clear fractions, couldn't I? Everybody agree now, if I were to multiply through both sides by 4, look what happens. I end up with x squared minus 8x plus 4 over 2 reduces to 2, and so I end up with plus 22 equals 0. That's a much better place to start, isn't it? So the first thing is put it into a correct standard form where a is positive, and it makes using the quadratic formula much easier. Okay, that's a good stopping point for today. Have a great day. Enjoy the sunshine. I'm here after school if you need me. Otherwise, I'll see you on Friday.